Hello, everyone. Thanks for coming out. Who's enjoying the conference so far? I definitely am. Yeah, it's so great. Selenium Conf is actually one of the few conferences personally where I feel like I come to see friends and family and a lot of people that are here have been working with in different roles for a long time and have become friends. It's great to come out here and see not only known familiar faces but also all the new folks that come out and join this conference. Also, big applause to the organizers who all put this together and allow us to have a great time. Thanks for that. This session is going to be about component testing with WebdriverIO. I know the title is a little bit awkward and lame. I wanted to call it something like break your end-to-end test into smaller components and run it at the speed of awesome. But that title would probably have been too long, so I stick with that one. Anyway, the goal of this talk is pretty much to help you get an idea of how you can break your end-to-end test into smaller chunks, focus on the UI or focus on APIs rather than testing the whole thing as a whole. And that ultimately will help you to reduce your end-to-end tests and run your tests more stable, more faster. And for that, you look into web components and how you can test it with WebdriverIO. Short introduction to myself, I'm Christian. I'm working with some wonderful folks over at Stateful, where we coined the term of README Ops, where we try to bridge the developer gap between projects and the developers and get them up and running. Get them up and running more faster and quickly. I'm maintaining the WebDriver project among some other folks. I'm a cross-console project member and represent the WebDriver project at Node.js Foundation. This is actually me talking at the first time in my life at the conference in Berlin, Selenium Conf 2017. And so it's always great to come back to Selenium Conf. Over the next 40 minutes, I want to look into a little bit, not only how you test web components, but give you like a little outlook about what web components are. Talk about a little bit about the testing principles around, the testing pyramid and how, writing more component tests will help you to speed up the tests. We look into the tooling landscape, what's out there currently that help you to do component tests, and then eventually look into how you can add WebDriver component tests to your project and do some live coding to show you all the demos. There's a lot of features that have been added in the last 3 months in preparation of this talk, so happy to show all these features live. And then we look into what's next. But starting with what are components, I'm curious who of you have heard about web components as a term? Okay, majority of fans. Okay, that's cool. Web components has been around for a long time, actually. Some people say a guy called Alex Russell has, suggested some of the ideas of web components having reusable HTML tags in 2011. And actually, 2 years later, Google released a framework called Polymer, and Facebook released a framework called React to make those, and kicked off basically a new era of front-end development with frameworks that have been, that rely on reusable UI components. Because developers back in the days were very frustrated with the status quo of developing this monolithic JavaScript application that followed this model view controller pattern, written in frameworks like Marionette.js or Backbone, if you remember those times. And so they were very frustrated. It was hard to maintain those projects. And with the era of these new front-end frameworks, kind of like a new era in development has been kicked off. It's very awesome to see, now the new tools like HTML, Stencil.js, Vue, Svelte, all the frameworks that are out there today allow you to write applications using reusable UI components. And what web components is, as a raw basic, is just a set of HTML standards, which you can see on the left. They don't need any bundlers nor packages or frameworks. You can write web components, basic web components in the browser. No tool needed to do that. It's like a set of 3 basic standards. One is the custom element standard, which allows you to write a JavaScript class with some custom functionality and register that class to the browser, and then you can use that custom element in your HTML. There's a concept of a shadow DOM, which allows you to encapsulate the style and separate the DOM. So no styles from outside can go into the web component, nor the styles that are defined for the web component can opt in or modify the elements outside of the component. And then there's this concept of HTML templates, which allow you to write HTML that is not immediately rendered in the page, but that you can use with JavaScript to attach it to something like the shadow DOM. And there are 2 concepts here, right? There's this term web component, which specifies the HTML standards, and then the term of reusable UI components, which has been, which has been used by React and implemented in a different way. Now we have frameworks like libhtml, which is something that I commonly use. It's really small wraparound web component APIs from the browser, but simplify, writing them using, things like template functions, as you can see here, where you can write your HTML right into your JavaScript files. But the procedure is the same. You register it to the browser, and then you can use it in your HTML. Again, React has been using the concept of reusable UI elements for a long time, even before web components have arrived and marked as stable in the browser. And they made it possible to, rendering the content of the component right into the HTML. You see there's no shadow DOM in this example. React doesn't use the web components. Others do, however, like if you use Vue or Svelte, you can opt into the web component experience by just enabling it by a flag in the configuration. And that's really nice because you can use different web frameworks for your application. You can use you can build web components built in libhtml, you can build web components built in Vue, and use them all in one application. Because you're not obliged to use one framework that does it all. So, and as Diego mentioned this morning, this has changed how developers build their applications today. And we have established our best practices for testing as well. Now we should, maybe think about, well, when the way we build application has changed, maybe we can change or amend the way we test applications as well. This gives me to talk about testing principles. And I think there's not one talk where I'm not going to come to talk about the testing pyramid, which is, for folks who don't know, is this pattern or this concept of putting different types of testing into different buckets with different granularity. And I still fully agree with the testing pyramid. It makes totally sense. However, given today's tooling space, it's very easy to get this wrong. For instance, I feel very comfortable writing WebdriverIO tests. I can write them fast, and they give me a lot of confidence. However, it will increase the top part of the pyramid and reshape it kind of like that it doesn't make sense anymore. So every day as a tester, we should facing the challenge to keep the balance between the amount of end-to-end tests, integration tests, and unit tests. At the end of the day, we should keep writing most of the tests as unit tests, keep writing most of the tests and integration tests, and only use end-to-end tests for small fraction of user scenarios. Now with writing more composable UI elements, we can there are some folks who looked at the testing pyramid and said, this really doesn't apply for the way we build applications today. There's a guy called Kenzie Dodds who created this concept of the testing trophy. And he really wanted to emphasize the question of what's the return of investment when writing tests. Writing end-to-end tests can be great, gives us confidence, but they are costly in execution and can be brittle, and there could be a lot of false failures. On the other side, unit tests, they run fast, you can execute them every time, but they might miss some bugs when we mix all these systems together. So he wants to emphasize the importance of integration tests, which really is, and I fully agree with it, which really creates this nice middle ground between the complexity and the confidence that we get from writing those, as well as from the execution time. So focusing more on integration tests rather than putting everything into end-to-end tests, or not writing any integration tests at all, is not what this concept tries to describe. And as an example, I feel a web application that is written for an iPad, let's say. It's a normal login form that sends credentials to a backend server, and the backend server is connected to the database. I think every one of us has been writing end-to-end tests for those kind of scenarios, right? The user puts in the credentials, backend checks if the database has these credentials or not. Now, we can write an end-to-end test for that, which is totally valid, but we there's a lot of details when it comes to testing those user flows. Like, does the UI show the correct error message if the request has failed? Does the UI show a correct, like a message that the credentials are valid if the credentials are valid? Like, how does the UI modify, what are the changes of the UI that we can test? There's a lot of them. The same for the backend. Are there any characters that the user has sent to the backend that might cause the backend to crash? Is there like an SQL injection attempt? Testing all these on an end-to-end level, maybe even on an iPad, would be very costly. We would probably not do that because spinning up an iPad could take time, and all those scenarios could be brutal, and there could be a lot of false failures. So here, it's really to improve the situation here, we can really break the test up. Don't write all of this in an end-to-end test. Have a lot of integration tests that only focuses on the UI. Have a lot of API tests that really focuses on the backend. Integration tests that checks if these systems can connect with each other. And then have only a few end-to-end tests for a valid and invalid scenario to make sure that all the systems work together. And you might say now, well, that sounds great, Christian. I will go back to my company and we'll write more integration tests next Monday when I come back from the conference. And you will face the ever-daunting question of what tool is the best. And there's some information you should know when considering choosing a tool. I did some experimentation, and to try to find out what tool is the best. The usually good approach especially for finding a good tool for component testing is, what front-end framework you're using. I've looked at the old React.js docs, and they have been suggesting Jest, which is not a surprise because it also comes from Facebook. And Jest allows you to access the DOM through something called JS DOM. Now, funny enough, the new React docs don't have any information about testing at all, which maybe will be changed soon. But all the frameworks are better. Vue, in this sense, has documentation around how you write unit tests, component tests, and end-to-end tests. But there's been a common pattern that I've observed, which is that most of the tools suggest you to write your component test in something called JS DOM. And JS DOM, for folks who don't know, is basically a re-implementation of the various browser APIs in Node.js. It basically emulates you a browser. And the project says that it emulates enough of the browser API to be useful for testing, which has been true for most of the time in the past. But today it's not the best tool that you can use anymore, because you can now run actually unit tests and UI tests in the browser using frameworks like WebdriverIO. So using JS DOM for UI testing is kind of like doing graphics work on an old Macintosh. There's a bunch of limitation that comes from using JS DOM. For one, it doesn't allow you to behave like a user. A click, like in JS DOM, you can only do click through throwing JavaScript events. A click through JavaScript is just not the same as a click in the user world. And I will show you in a minute what that means. There's some missing APIs, no ASM support, no fetch API, and so on. It's difficult to use the canvas. Web APIs might be implemented differently than, for instance, on the Safari. There's no cross-browser testing ability, and there's no ability to test solid states. I've been seeing a lot of teams, front-end teams, that have been writing UI component tests where they just render the component and check if no error is thrown, and they feel confident that the component is tested then, because they don't feel able to test the component in any other ways. Now, and if you have using the testing library and you were you couldn't find an element, you can inspect the screen, the virtual DOM, and you get something like this, which is just a horrible developer experience. You cannot really understand how the application looks like in this format. And I did some other tests. I took again our login example, our login component, and I wanted to check how it's like to behave like a user. Now, let's say we have a component that hides our login button, which is just under the credential or under the inputs, that will hide our login button with the CSS attribute of visibility hidden. With JS DOM-based tools, click would still happen, your test would pass even though the button is not visible. Which is in browser-based tools like WebdriverIO or Nightwatch, if you do component testing with that framework, the click would not work because those WebDriver checks if an element is visible and interactable. The same goes for if you set hide 0. Click still works in JS DOM. Or the scenario of what happens if an other element is on top of the element that I want to interact with. Same here, JS DOM-based tools. Click on an element, click works. Browser-based tools, especially WebDriver-based tools, they check if an element is interactable. One experiment I found interesting is what happens if I just move the element completely out of viewport. So usually a browser driver tries to bring this back into the viewport, and actually Cypress and Playwright are very aggressive with that. So they can move it back to the viewport in a way that users couldn't, but WebDriver kind of like can detect those kind of things. Furthermore, there are some things that you cannot do with JS DOM-based tools, which is scroll action or pinch zoom, when you use multiple fingers to kind of like zoom into an element. Those kind of things are also only supported with WebDriver-based tools through the WebDriver Action API, which is very powerful. And lastly, one of the most important features, I feel like, for UI component tests is the ability to mock out modules that are outside of your component scope. In this case, I have an Argolia search component, and I want to just mock out the Argolia search dependencies because I don't want to make any requests to a backend server. I just want to check the UI of my component. I want to test my component and not other people's code. So mocking in the browser is currently only supported by WebdriverIO, also supported by JS DOM-based browser because Node.js can change the modules in runtime. All the other frameworks, they have it still on their roadmap. Now, you might now be convinced, cool, I guess WebdriverIO is the way to go. Let's set it up in our project. And the one command that you should remember is the npm init WDIO at latest. That allows you to just get set up and started. And this will spin up a configuration wizard. The configuration wizard will walk you through a couple of questions and will install everything necessary for you to get going. The first question will be if you want to run your test in Node.js as an end-to-end test or in the browser as a UI component test, right there. Here you pick browser. Then you get a list of frameworks that you might use for your project already. So if your framework is in there, if you use React, you just pick React. If you use a different framework, you pick others, and you can still set it up. Then it asks you if you want to use testing library. I was a bit hating on it before, but it's actually very useful for UI component test in order to render the component into the browser and clean it up afterwards. Other than that, the questions are still the same as you would do end-to-end test. You could use a SAW service or browser stack service if you want to run your component test in any of those cloud browsers, if you, for instance, don't have a Safari and want to test on Safari. At the end, you will get a basic example component and a basic example test, and you can run it in a headless mode, as you can see here. It runs very fast. If you don't run in headless mode, you see this experience. When the browser pops up, you usually see the web component under test on the left side in the sandbox. Then you see the HTML reporter in the middle. And what's really nice is you can now open the console and use the WebdriverIO API within the terminal, within the console right there, which is really helpful if you want to fiddle with selectors and want to check if the commands work. In this case, like I test if the move to command actually triggers the hover effect in my Svelte component over there. So that can be very useful, especially for finding elements. The DevTools console has an accessibility tab that gives you the accessibility name of the component. I always recommend to use accessibility selectors to find elements, especially inputs and buttons. And so what you can do here is just to go on the accessibility tab, find the accessibility name, and put it into a WebDriver selector and verify if you can find the element or not. Enough showing GIF animations. They're fancy, but don't show the real thing. Let's do some live coding. Before I do so, however, I want to get a glance of what people use in this audience. Given that all these frameworks are supported, I want to show an example that actually reflects with most of them. Who of you is using React in their day-to-day world? Okay, get some hands. Preact? No Preact user? Vue folks under us. Okay, 2 Vue folks. Svelte? Lit? Any fancy solid folks here? I guess not. Okay, let's do React then. I still most people for React. So I created a little example project. And we do the React case. And what this project has is basically just one component. It's not a whole website or anything. Just want to focus on one component now. It's a simple our login component that we know from our slides. Simple, email, password, and submit button. And then there's a WDIO config that you can see here has now this runner configuration that defines that all the tests are being run in the browser with a preset of React, since I'm using testing a React component. And I'm running it hasslessly by default unless I provide a debug flag. So let's get started. And oh yeah, one thing, our login component uses this module here, which can be anything, any authentication module that you use. In this case, it's just a simple login function that does a fetch request to log in the user. But let's get started writing a test. We call it demo.test.tsx. And let's first say seconf demo test a valid scenario. And let's just verify that we are running in the browser here. So we do a console log, and we say we use a window API to say, okay, give us the user agent. Those kind of things can only run in the browser. And then we run our WebdriverIO, and I suppress all the logs to just see what we print out there. And voila, we see that we're using headless Chrome in version 111. You can just go for the fun of it, go back and change the browser name to, let's say, Firefox, and set the service to Gecko driver. And just rerun this. And now I should get a Gecko browser. So I can test in all browsers. I could hook it up with, again, a cloud render if I choose to. Okay, let's log in. Let's render our component into our test. For that, we import it first from our login file. And then, again, in order to render a component into the browser and to stage it, we should use the render method from the testing library helper. And that allows us to just say render login component. And so to avoid that this thing is being cleaned up, we do a breakpoint here so that the browser waits for us. So we want to see the browser, so I provide this flag, and I apply the watch flag, so the tests are being watched. And there we go. So now we see the element, our web component here in the browser and our HTML reporter. We can now go into the dev tools, and we'll make this a little bit bigger. And we'll hide info and warnings. And now we can see that you can use the browser API, the WebdriverIO API here. So let's find an element, go and inspect. Again, open the accessibility tab, and this will tell us the accessibility name is email. And so we can, let's say, set the value by using the accessibility selector, say email, and we set the value hello@gmail.com. There we go. We do the same for the password. That works. Okay, now we want to click on the button. It's a login button. So everything that the button name is always the accessibility name, and we can do a click on it. And then we see a request is being made, but the credentials are wrong. But we have our first test here. So we can all move this into our test. Do it this way. Click, and then we say, we can even test assertions here. So we expect that our password, in this case, our password to have element class, which is and I know this is invalid. So just to verify that this works, if I do not, it will fail after some retries. Yeah, so this is our assertion. We can also copy this over. And saving it, it will make the test pass. But you can see that we still have this request being made, which we don't want because we want to test our framework in isolation. So for that, we want to mock out our module. So there are two approaches here. We can say, okay, we just mock the fetch method, which is globally accessible in the browser, or we can just mock out the WHOOL API, which sometimes is simpler. To mock out things, you want to import the mock function from the browser runner, which has a similar interface as the mock function in Vitest or Jest. And the way you use it is you define the path to your file that you want to mock out, and you provide a function that returns whatever the module should be now. In this case, we look into our API, and it seems that we return or export a named function called login. So we want to mock this out. We copy the function name, and so we turn an object with login, and instead of calling it, we mock it out with a login function. We can also import this from the browser runner. And then it's a promise, so it returns a promise, so we say the mock should resolve with a value called token 123. So this would be a successful case now. We can save that, and we have to restart our test. Now you will see that, oh, our login was successful. Test fails because it expects an invalid test. So we can just move this to not. So this is a valid test now. It does test the successful user flow, but as you can see, I will restart it now. There's no backend request made because the API module is completely mocked out in the browser. This is all thanks to the power of Vite, which is used by WebdriverIO to power these component tests. Let's just add one more to demonstrate how we can change the mock dynamically. Let's say this should be now an invalid case. Should be invalid. And so in order to modify our mock, we can import it. So we can import login from our API. And this is not importing the actual file. It's actually importing this mock here. And for type reasons, I need this thing. It's also similar to the jest API. I need it for better typing. The mocked login function should now resolve with an error. And we save this, and now we have two test cases that the request is not being made. It's actually just modifying the mock or API to return with the expected responses for our test case. So the backend is completely out of picture here. Another feature that I want to show off is coverage reporting. Now with that, we can actually now go in and make sure that every part of our component has a test. And like many other coverage test runners, you can have like a coverage property in the browser runner options, and you can enable it, enabled true, and then you can define how many lines, how many functions, how many branches you want to cover. And I can say here now, okay, I want to have all my lines covered. 100% of the lines of my code should be covered. So running our WebdriverIO test now without the watch will pass, but we see that no, we don't have 100% coverage. Why is that? We can check out the coverage report, which automatically creates an HTML page, and we spin up a static server. We can look into the files that have been tested, and we see that there's one line of code that has not been tested, which is the case where I don't put in any email or password in my test. So let's make sure we cover that. Let's go back into our test. Let's modify and add another test to it. And in this case, we don't provide an email. And this time, it should be invalid. Yeah, should be the same. This we don't need because we don't make a request to the backend in the first place. And that looks good. Let's see. Oh. Let's run this again. And hopefully now, 100% coverage. There we go. Checking the HTTP server again. There we go. This time, we have covered the complete React component. All right. I'm going back here. Cool. I want to wrap up this talk a little bit about what's next in terms of component tests. So the part of using WebDriver for component tests as well as for end-to-end tests is that now you can create page objects, but you can create page objects earlier in the development flow. Like your developers who maybe write component tests, they can start writing the page objects because the elements and the locators will be still the same, and you can reuse them in your end-to-end tests to use them to test the whole stack. So using WebDriver for component and end-to-end tests, you can reuse a lot of code in terms of page objects. Something we want to look into to improve some mocking capabilities. There are some edge cases where when you redefine the mock paths, that it doesn't automatically pick it up. Also, you cannot use mocking for when you run browsers in parallel. We are working towards improving that and make it more stable. We want to support more test runners. Right now, there's support for Jasmine. There's support for Mocha.js, which is fine, works for most cases. But if some folks like to use Jasmine or Cucumber, they can use that too. We're looking into adding a snapshot testing feature. Basically, what this means is you can say, you can put in a component and say to match snapshot, and it will take the DOM tree of the component and will store it in a file, and you can revisit the DOM tree and see, is my component in the state that I expect it to be? Does the component have the button rendered? Are the right CSS classes applied? It makes, it allows you to cover more, to cover the test, increase the coverage of your expectations. And furthermore, we kind of look into some image comparisons. So you can do a snapshot, a screenshot of the component, and then do a component image comparison, pixel by pixel. That could be useful. And then we want to further improve some of the front-end frameworks. Right now, while you can test AngularJS with WebdriverIO, it's still, the documentation are not really there, and we don't have a preset for Angular yet. Someone is already working on it, but we would like to improve the support there as well. And lastly, whatever you think is useful, right? It's a community-driven project, so give WebDriver a spin. And if you find any issues or would like to see features, log a report. We can help you, either contribute yourself, or we can see if we can put it on our roadmap as well. With that, thank you so much for being a great audience. I hope this was insightful, and I'm opening the floor up for questions. Thank you.
So I do have one question. By the way, Kristen, you and I know each other a bit. I'm Dark Arts Wizard, so I've been playing with your tool for about a year and a half. The question I wanted to put out there was support for soft asserts. Let's say I've got a page, I've got a full address, first name, last name, address, city, state, and zip, and the name is wrong. The first name is wrong. I want to validate the other fields. Is there support in WebdriverIO that you can do soft asserts so I can validate all the multiple elements on a page without having the whole thing stop at my first name being wrong?
I'm not sure. There's an issue for that open, I remember. And I'm not sure if our expect library, we use the one from Jest, if that supports it. So we are basically rely on the Jest expect library to make this happen. And I think they haven't supported it. And we can make support happen there, and then it automatically would be supported in WebDriver.io. But I think so far it's not, unless you use your own assertion library, like Chai. I think that would support it. But it would require you to use your own assertion library, which you totally can do.
Thank you. I like the fact when you split the screen, where you find the elements. Mm-hmm. I'm currently using the V7 right now. Do we have this feature in V7, or it's upgraded to V8 only?
The browser runner is only possible for V8, unfortunately.
V8. All right. Thank you.
But if you have any problems with upgrading to V8, you can reach out in the community channel, and people will help you out.
Sounds good. Thanks.
Yeah. So yeah, Christian, I absolutely love it. I can't wait to add native support for it in Serenity.js in a moment. But the question I have for you is, who would you expect to write those tests? Would you see more testers write component tests? Would you expect developers write component tests? Is there a mixture? What's the ideal scenario here?
That's a good question. I think for me personally, when I write a component, a web component or any kind of component, this is perfectly suited for writing tests while you develop it, right? You saw that I can show that off. We have some time left. If I just kick this off once again, Your right folder. So this is run by Veed, and Veed has auto reload capabilities. So I have my test run fine now. So I can now develop on my component, and I say, okay, what happens if I don't know, if I do just nothing in my submit handler, and I reload my test, and you see that the test failed. So I can modify my component, make changes to it, and have WebDriver run the test while I'm developing the component. So you can you can develop the component and see if the tests work at the same time. So I would assume, well, that gives me headaches. I would assume, and every team can do this differently, but this is very suited for developers who write components. And especially if they also start writing the page object for them, because if they then have a QA team that does the whole end-to-end test for the application, they can reuse the page objects developed by the developer already. It's ideal this situation is ideal for both developers and QA engineers. And ideally, yeah, I would recommend a developer starting writing WebdriverIO test while developing it. We got 5 more minutes. I can answer any other questions about weather, politics. No, better not politics. All right, I think we can have an early break then. Sounds good. Thank you so much.